All right, so we're ready to get back into the swing of things here, and we're going to start off by talking about the introduction to sequences and series. So first of all, what is a sequence? A sequence is basically a function whose domain is going to be the set of positive integers. So if you wanted to write it out as a set of ordered pairs, you'll notice that the domain right here starts at 1 and all the positive integers. And then the range, we represent it by a sub 1, a sub 2, a sub 3. And this would be like your general term of n and a sub n. So if we look at this example of our, even integers here, 2, 4, 6, 8, keeps going on and on. This would be an example of a sequence who's increasing by 2 each time. And you can write it in the ordered pair form, where you can see your positive integers here, and then here are your terms of your sequence. And if we wanted to write this general term here, you can imagine what you're doing if this is your n. What you would have to do to get this value is multiply by 2. So we could write this as n comma 2n. So what we just did here is we created a rule to describe our sequence. So a rule is just a pattern. It's something that describes the pattern, in terms of n. And it's going to be an expression that you're going to have to work out, and you can do pretty much anything you want to the n. You can multiply it by numbers, subtract numbers, add numbers, raise it to powers, have n be the power, all sorts of different things to describe whatever pattern you see happening when you move from one term to the next in the sequence. So if we take a look at this, they ask you to find the rule for this sequence 2, 1, 0, -1, so on and so forth. Until you get really good at these things, it might be really challenging. And all I can say, the advice I can give you is just keep trial and error, test things out, kind of see what you're doing, getting from one term to the next that might help you until you do enough of them, and then they'll become much easier. So for this particular sequence, what we can tell is that we are decreasing by 1 each time. And when that happens, when you have a constant number that you're either increasing or decreasing by, that's going to be your n. You're either adding or subtracting n or multiples of n, depending on how much you're increasing or decreasing by. So in this case, we're decreasing by 1, so that would be like a -1 times n. So that would be great and all if the first term happened to be -1. But it's not. The first term is 2. So in order to get 2, if we have -1 as being what we have there, to get 2, we'd have to take 3 and subtract the 1 in order to get the 2. So long story short, what that tells you is that your nth term is going to be 3 minus n. So that's going to be your rule. So test it out. If you plugged in 1 for n, you get 2. If you plugged in 2 for n, you get 1. If you plug in 3 for n, you get 0, and you can keep going as far as you want. What this rule actually does is it allows you to, say, evaluate or figure out any specific term in a sequence. So if I asked you what is the, 14th term in this sequence, you can take 3 minus 14 and figure out that it's -11. Okay, so moving on. Wanted to give you some variations of simple rules for sequences, just to help you out in case you're having some difficulty with this. So like I said, you can multiply n by any number, and you can also add and subtract numbers from that. So like we saw with the even integers, 2 times n, that gives you 2, 4, 6. 3n plus 1, so that would give you 4, 7, 10. You can see how the difference between these numbers is always a constant 3. But we didn't start with 3, we started with 4, so that's why we added 1, and all of these are just off by 1. We can always raise n to a power, so n squared, n cubed. You can raise it to a negative power, n to the -1 if you wanted, n to the -2. Or you could have n actually be the power, so you can have some number, some constant here raised to the n, and so it's the exponent that changes every time. All right, and you can do any kind of combination of these things to get your rule. All right, so what is a series and how is it different from a sequence? Well, a series is just taking a sequence and adding up all the terms. So if we look here, our sequence 1, 2, 3, 4 versus our series 1 plus 2 plus 3 plus 4, and you can keep going as far as you want to go. Well, in a series, because you're actually adding these numbers together, you can get a sum, right? But if your series goes on forever and ever, you can't get this sum of an infinite series unless it's a very specific case, which we'll look at later. So what we're going to be doing is actually looking for a partial sum. So that means just the sum of the first n number of terms in your series, and they'll tell you how far out they want you to add it up to. There is a Greek letter sigma that represents sum, so this is kind of a shorthand way to write a series instead of writing it all out like this with the plus signs. So here's an example, and I'm going to talk about all these things that are kind of sitting around your sigma. First of all, this 2k, this will change, this will be different every time. This is like your rule, and you're going to use that to calculate all the different terms in your series. The k equal to 1 down at the bottom underneath your sigma, that's telling you the value of k that you're going to start plugging into your rule in order to get the first term of your series. And you're going to keep plugging in values of k, increasing by 1 each time until you get to this value up here. And that's when you know you're done, after you've plugged in that top value. And it's important to note that k needs to be integers. It could be anything you want, positive, negative, it could be 0. It can start anywhere you want. It doesn't have to start at 1. It could start at 3 if you wanted to. But this number is always going to be less than the number on top because you are always increasing k by 1 until you get up to that number. Okay? And k is considered the index of summation. So if we looked at this series and we plugged in 1 for k, and then 2 for k, and then 3 for k, this is what it would look like. Expanded, you can simplify it out and get that the sum, the partial sum of this series for the first 3 terms is 12. And I know in this case it was very obvious since k was equal to 1. Anytime k is 1 at the bottom, it's very clear how many terms you're going to have. It's going to be the number that's up top. But that's not always going to be the case. And we'll take a look at that in a minute with a couple of examples from now. Okay? So here's another example. It'll ask us to evaluate. A little bit more complicated rule, but not too difficult. So you go through, you plug in 1 for k, and you get 3. Plug 2 for k, you get 5. Plug 3 for k, and you get 7. And then you finish off by plugging 4 for k, and you get 9. And so then you can add those up, and you get 24. Okay, once again, we started with k equal to 1. We went up to 4. There should be 4 terms here. All right, next one. We have the sigma, but this time k is equal to 0. That's where we're going to start. And we're going to go all the way up to 5. So if we plug 0 in for k, what's going to happen is that's going to give us the very first term of our series. It doesn't give us the 0 term. It gives us the first term. So when we plug that in, we get -1. But then we plug in 1 for k, because we increase k by 1 each time. That will give us the second term. So we get 2. And then we plug in 3, we plug in 4, we plug in 5. So we get our terms here. And so then, let's see, 0, 1, 2, 3, 4, 5. I guess I was off when I did that. Anyway, so we're done once we plugged in 5 for k. And you can see here how this is your first term, second term, third term, fourth term, fifth term, sixth term. So in this case, when k was equal to 0, if you were just specifically asked how many terms are in this series, you can't only look at the number up top and say that it's 5 terms, because in this case it's actually 6. And, what if I had said k was equal to 3 all the way up to 5? So, that's going to start you off at a different term. That's going to start you off right here all the way up to 5. So then there's only 3 terms instead of the 6 that we see here. The last thing that I want to point out is the different words here. We had evaluate up top and we have expand down here. In evaluate, that means that they want you to actually write it out and then figure out what the sum is. In expand, they just want you to write it out. You don't actually have to go the extra step of adding those all up together. They don't want the sum. They just want it to be written in expanded form. Okay? So that's that, a good introduction to our sequences and series.